Alright, this is Schweitzer, and welcome to a level 3 question. So this is our baseline question we would want, we'd want everybody in our class to be able to solve this type of problem. This problem involves adding two vectors together. In order to add these two vectors together, you would need to break them apart, add them up, and rebuild a new vector. So take a few moments and give this a try. Okay, so here's the answer how to solve this problem. First things first, we need to break these into components, and a mag table is pretty handy for this. Magnitude, angle of this guy, and then x, y, and z are our components. We break it apart, and of course I have this done already for you. This is considered a little easier, but you need to take SOHCAHTOA and break each vector. The bolt vector is got 10 degrees. Now I took 80 on this guy because its absolute angle is 80, and then I get 2.6 and 14.7. This river is traveling straight east. All right, so that means going straight to the right. That's 3 and 0, and the z, of course, is 0 for both of them. There's no up and down motion, at least not that we're describing. Add them together. These guys I can add together. We have 5.6 squared, 14.7 squared. Using the Pythagorean theorem gives 15.7. That means I have a 5.6 to the east, 14.7 north, and I want not only I want the magnitude of this line, and I also want the angle here, either this angle or this angle. Either one will work. So to solve this, I use Pythagorean theorem. So my magnitude is 15.7. That's the length of this line, which is my new magnitude, and which is representing a velocity in this case. And then my angle is 69.1. Of course, that's this bigger angle right here. So I took the opposite, which is the 14.7, over the adjacent, which is 5.7, inverse tangent this thing to get 69.1 degrees. Now again, this is not necessarily a video on just the how to use a tangent. If that's the case, there are resources available for that. But 90 minus the 69.1 is 20.9. So we could use this angle relative to the east mark or this angle relative to the north mark to describe our particular answer. So if I were to write a whole vector out for this thing, it would be 15.7 meters per second. And then we could use, let's use a small one, 20.1 degrees, and this would be right this angle here. I subtract from 90 to get that guy. That'd be east of the north mark. East of north. The other way we could do it is going to be 15.7 degrees or meters per second, and that'd be 69.1, and it would be north of east. Alright, and that is the answer to this question. Either one is, in our opinion, is acceptable. The smaller angle might be more desirable, but thank you very much.